Right, example 5 is one involving an E, and it's actually a very important curve in statistics. Okay. It's a curve, it's a bell curve, a curve that represents the normal distribution, but we're going to just approach it as a calculus problem. Okay. So running through your what you know. Okay, so we're thinking about those graphing guidelines. We might want to think about the domain here, and like a y equals e raised to a positive variable versus a y equals e raised to a negative variable. E to the t does that. E to the negative t does that. Okay. Okay. And they actually have horizontal asymptotes to them too. Both of those do. So might want to just kind of discuss that while we're at it. So when we're looking at this, you can plug in anything. There's nothing you have to worry about plugging in for x. So the domain is all reals. And then we might want to think about the limit of the e to the negative x squared as x goes to positive infinity. Just to think about what while I was drawing these graphs, to think about what the end behavior is. So if you put in a positive infinity and you square it, that's going to be positive, and then you do the opposite of that, that's going to be a negative, really big number. So it's going to be doing this as you approach positive infinity. So that means the limit as x approaches positive infinity is going to wind up being 0. Okay. So that's going to wind up approaching 0 for the end behavior. All right, now, if you wind up letting x approach negative infinity, you're squaring it, aren't you? So that's still positive. Then you'd have negative of that. So it's going to approach 0. Okay. Now, this isn't what your overall graph is going to look like. Okay. But I just use that to try to think through what the limit would be of e raised to like a negative infinity, okay, would be. So that's not, I'm not claiming that's what the picture is. I'm just doing that to get an idea of what's going to happen when we plug in really big positive or big negative numbers. So y equals 0 is going to be the horizontal asymptote. Okay. So that's kind of like good to know. We might as well do it while we're thinking about domain. There's no vertical asymptotes at all. Okay. All right. So symmetry we might talk about too, because did you notice how whether I plugged in a positive or negative infinity, I'm going to square it. So I'm going to get the same thing either way. So this is an even function. Okay, because if I did f of negative x, I'm going to get e to the opposite of negative x squared, which turns out to be the same as that, which is f of x. So what that means, it's going to have y-axis symmetry. So that helps me, kind of like the previous problem. I needed to have it being symmetric about the y-axis. Okay. All right, so now first and second derivatives. Let me jot those down. We did those earlier, so we're not taking time now to do those. Okay, the first derivative wound up being negative 2x e to the negative x squared. And the second derivative wound up being 2e to the negative x squared, and then 2x squared minus 1. Okay. All right, so possible maxes and mins would be where this equals 0 or is undefined, but it's never undefined. And then possible inflection points would be where this equals 0 or is undefined. But again, there's no issue. You can plug in anything you want there, and it's not going to give you a problem. Okay, so we don't really have to worry about that part of it. So we need to know, when is this going to equal 0? Okay, And so you can think about this as being a product. So we know it's going to be 0 when that's 0, or if it's possible to make this 0. But this is not possible because e to some negative number or e to some positive number, this is e to a negative number doesn't wind up overall becoming negative. That negative exponent really just means 1 over e to the x squared. So if you plug in something here, positive or negative, you're going to be squaring it. Okay, so it'll be positive, and e to a positive number is going to wind up just being some number. Okay, so you're not going to wind up, this is never going to be 0. Okay, so that's not possible. So x equals 0 is the only place where you could potentially have a critical point, have a max or a min. Okay, all right, so let's check. When you're over here at 1, what happens? Okay, so if you plug in 1 for x, this is negative, this is positive. You put in a 1 there and square it, you'll have e to the negative 1, and e to the negative 1 is just 1 over e. That's positive. You see that? See that e to the negative x squared, this right here is always positive. So when you're over at 1, you're going to have negative, okay? All right, and when you're over at negative 1, you're going to have a negative, and then a negative, and then this is always positive here, so it'll be a positive when you're here. So that's plugging into f prime, but it's telling us where f is increasing. So it's increasing here, and it's decreasing there. Okay. All right. All right, so that means if it's increasing and then decreasing, then this is a max. And so we can plug that in to the f function. And remember, f was, what was it? Was e to the negative x squared, f of x equaled e to the negative x squared. So if I plug in the 0, e to the negative 0 squared is e to the 0, that's 1. So that's right there, the coordinates of the max. Okay. Okay. All right, now let's take a look at what causes f double prime to equal 0. Those will give us the possible inflection points. So this would equal 0 whenever this is equal to 0 or when this is equal to 0. But for a similar reason, e to a negative number is just 1 over. This is going to be positive, so this is never going to be 0. Okay, so you don't get any x values from there. And then here you might add the 1, divide by 2, and then take the square root. Okay, and you could rationalize, but that's not normally so important in calculus. And those are possible inflection points. Okay, so what I'm going to think about, and I'm pretty much putting this and this. Let's go ahead and just put them all together on the same picture and think about what's happening there. Okay. All right, so anywhere on the left of 0, my function is increasing. But what we need to know is, well, what happens with f double prime there? Because I already know what happens with f prime. So let's pick something that's over here to the left of that. So like pick something like negative 1. Okay, if I pick a negative 1, all right, here we are. All right, so if I pick something there, like a -1, sorry, and get back to it, I'm looking for whether that's positive or negative. So let me just think about that as I plug it in. Okay, so when I do that and I plug in a -1 and square it, I'll have 1. E to the -1 is positive because it's just 1 over e times 2. So this whole part is positive. That's always going to be positive. If you put in a -1 here and square it, you're going to get 1 times 2, which is 2. And when you subtract 1, you'll get 1, which is positive. So see, it's going to be positive here. Now it has y-axis symmetry, so that tells me that it's going to be the same when I plug in a +1. It's going to be positive. All right, and then let's pick 0, something easy to plug in there. When I pick 0, I wind up getting e to the 0, which is going to be positive because it's 1, so I get a positive. When I put a 0 in here, I get a negative, don't I? So this will be negative when I plug in 0. And so this is going to be negative here. All right. So it's got to be, it's going to be concave down. So let's think about F. It's going to be concave down between -1 over square root of 2 and 1 over square root of 2. Okay, so it has to be, and then let's put the increasing and decreasing in it, but it's going to be down here. Okay, it's going to be, no, it's going to be up here, sorry. And these are the places I was checking. It's going to be down here. It's going to be up here. All right, but then as you look further, it's got to be increasing in both of these spots. So it's got to be increasing here. It's increasing here. Okay, so when you go there, and also between -1 over square root of 2 and 0, it's increasing. Okay, so if you split it up into these little pieces, okay, and then it's down and it's got to be decreasing when you're there, and then it's got to be up when you're over here, but still decreasing. See that? All right, and that up, down, up means that these are actually going to be inflection locations of inflection points. And this one too is going to be an inflection point. Once we find one of them, we're going to pretty much know the value of the other one. All right, so let's take a moment to go ahead and get the y value of that. We already know where our maximum is going to occur. These are going to be places where we have inflection points. And then we've got what's going to be true about F. So we had what we got from our concavity sine graph, and then I just pulled this over here also, okay? All right, so let's go back. We've got to plug these into the F function. And F of x, remember, was e to the negative x squared. So if you plug in a -1 over the square root of 2, I'll do it exactly and square it. Okay, that's going to equal e to the negative. That'll be +1. Square root of 2 times itself would be 2. So it'd be inside here, this part would be a 1/2. So you'd have e to the -1/2. Okay. All right. So when you get that e to the -1/2, remember that's equal to 1 over e to the +1/2. And remember, raising something to the 1/2 power is really a square root. So it's 1 over the square root of e. Okay, and that's what I got when I did this one, but this is symmetric, so I'm going to get that over here as well. Okay. All right, and then let me get the decimals for this. So this one is about -0.71, and then 1 divided by the square root of your e. Okay, this is not my usual calculator. Let me find my e. There it is. Okay. And you get about 0.7. 0.61. And that would be positive on both of these. Okay. All right. All right. So let's see if we can look at that portion. And don't forget also that we know 0, 1 is a maximum value. And we don't have any, there's no x-intercepts because we have an asymptote there. Okay. But we know the y, and it's always positive. So everything's going to be above. Let me make that a little further down. Everything's going to be above the x-axis on this. Okay. So we're going to be here 0, 1. We make it kind of big. Then if that's 1, 0.71, 0.61. Okay, so that's 0.5. That would be 0.75. So a little less than that. This is 0.5. It's going to be a little less than 3/4 and a little above that. And then negative 7.1, same deal. So let me get my 1 on there. Okay, this would be a half. So this is 1, negative 1. This is 1. So that's negative 0.5. This is negative 0.75. So a little bit less than that. And up here, see the symmetry? These are inflection points. This is a max. Okay, now let's get the sketch the way we need it to be. Okay, so I need it to be, when I'm working on this section over here, from negative infinity to the negative 1 over the square root of 2, which is right there. I need it to be concave up and increasing. And this is an asymptote right here. So it's got to get close to that. So it's going to be concave up and increasing. But at that inflection point, it's now going to become down, but it has to still be increasing. So it's still, the function still has to be rising, but it's going to be rising at a slower rate. See how it's getting less and less positive? Okay. Then it continues to be concave down, but the function has to be then looking like it's decreasing. So it's going to go like that till you get to here. Okay. All right. And then after that, I'm over on this side. I have to continue decreasing, but it has to be concave up. So it's decreasing. So the graph is falling, but concave up means that it's less and less negative. Okay. Okay, so the graph is falling, but it's concave up because it's getting less and less negative. So it's decreasing, but it's decreasing, and it's actually, the number is actually getting bigger and bigger and bigger. The slope values are getting less and less negative. So the slope is actually, so it's decreasing and concave up when you're there. Okay. Okay. All right. And then that's an asymptote. So it kind of gets close. And there should be symmetry, so it should match up. You should be able to fold it up. And then this in stats, this is the normal curve. And those inflection points are important because that's about 1 standard deviation away from the mean. And this will be the mean. And this will be 1 standard deviation away from the mean. And this will be in the positive direction. This will be 1 standard deviation in the negative direction. Okay. All right. So that was example number 5.